Welcome to EYNTK, everything you need to know. Today, we'll be solving questions on matrices based on properties of determinants. As we have here, our first question. Using the properties of determinants, prove that we have our first row, second, and third row. This is a 3 by 3 matrix. So our first row, 1A, A cube. Second row, 1B, B cube. Our third row, 1C, C cube. We're meant to prove that it is equal to A minus B times B minus C times C minus A times A plus B plus C. So we proceed to our solutions. So first of all, let's write the matrix back again. 1, 1, 1, A, B, C, A cube, B cube, C cube. Okay, so first of all, based on this, we're meant to this is the answer we're driving at right here. This is the answer we're driving at. So we're meant to solve it in a way that we'll get this. So first of all, the first thing we do is to subtract to reduce the equation, to reduce the expression, in order for it to be easy for us to find our determinants. So first of all, we'll subtract. Let's say, let's row 1 be row 1 minus row 2, and our row 2 be row 2 minus row 3. So let's continue from there. Write again our matrix. For row 1, that's row 1 minus row 2, that's 1 minus 0, that's 0, 1 minus 1, sorry, that's 0, A minus B, and A cube minus B cube. Or row 2, 1, row 2 minus row 3, that's 1 minus 1, that's 0, B minus C, and B cube minus C cube. Then our row 3, that's 1, C, and C cube. So there we have it. So from there, we proceed to finding our determinants for this expression. So now, if we take our determinants based on this part, it's going to be 1 into our new matrix. A minus B, B minus C, A cube minus B cube, and B cube minus C cube. So here we're trying to, the next step, like looking at this expression, we see that it is similar already. It is a little similar to this, to what we're driving at. And since it's similar, for us to get something relating to that, we have to factor out some things. And looking here, we see that A minus B is common on row 1, B minus C is common to row 2. So we have to sort this out to simplify it. So first of all, we'll see our A cube minus B cube is equal to, first we take our A minus B out, times A square plus AB plus B square. And also our B cube minus C cube is equal to, first our B minus C out, B minus C, B square plus BC plus C square. So now we can impute it back into this matrix here to be able to factor it out. So we write again our matrix, our new matrix. A minus B, B minus C, A minus B into A square plus AB plus B square. And also the second row, B minus C times B square plus BC plus C square. So close it. So now we are factoring this out, seeing that we have A minus B here, A minus B here, B minus C here, and also B minus C here. So we can factor that out. So factoring this out now, we would have A minus B times B minus C into our new matrix. Sorry about this. Into our new matrix, we'll be having 1 here, And this that we're doing now is based on our fourth property of determinants. The fourth property of determinants says that if an element on the column or row of a determinant, if an element on a column or row of a determinant is multiplied by a constant, it's the same thing as the whole determinant being multiplied by that constant. So looking here now, we see that this row is multiplied by a constant, a minus b, a minus b. It's common to both sides. This row is also multiplied by b minus c, b minus c, because it is constant. It's a constant that is common to both of them. Be it a row or a column. For example, if we had a minus b here and a minus b here, we would have factored it out also, because a minus b is going to be taken as a constant multiplying the column 1. Same thing for this side, but here it's multiplying the rows instead. So factoring that out, we factored a minus b and b minus c out. A minus b, b minus c. Here we'll have 1 here, since we're factoring it out already. And then here we'll be left with our a square plus ab plus b square. And our b square plus bc plus c square. Okay, having that now, we would find our determinants using these two. Our determinant here now is going to be to multiply our right hand side and subtract it from our left hand side, like this minus this. So this is our right hand side. We multiply these two values and subtract it from our left hand side, these two. So from there we would have our a minus b times b minus c. Multiplying now, we would have b square plus bc plus c square. That's because this equation times 1 is still the same equation. Same thing with this side, minus, because it's our left hand side this time around. So multiplying this by 1 will give us the same expression again. A square plus ab plus b square. So from here now, we can open these brackets to simplify. So to do that, it's best for us to introduce our brackets here to make it easier for us. So we're opening the brackets now. That's the next step. A minus b times b minus c. Sorry. Then times b square plus bc plus c square minus a square minus ab minus b square. Looking here now, we can bring the ones that have that we can bring the like terms together. Sorry, like terms. So we're collecting like terms now, like bringing them together. We have a minus b, b minus c. These ones are the ones outside. So in the brackets, we can bring the like terms together. B square minus b square, bc plus bc minus ab plus c square minus a square. So we can close the brackets. Yes. So looking at this now, b square minus b square is 0. You can cancel out. And looking here, b is common to these two, so we can factor b out. So let's continue from there. A minus b times b minus c into our brackets, b into c minus a plus c square minus a square. So here now we have this. So coming down here now, the next thing is to simplify these squares to make it linear. So recall, using perfect squares, we remember our c square minus a square is equal to c minus a first of all times c plus a. Yes, for perfect squares. So this is what it would be. Sorry, difference of two squares. I made a mistake. Difference of two squares. Sorry about that. So c minus a times c plus a. So substituting it back into the equation, we have a minus b times b minus c into b into c minus a plus c minus a and c plus a. Yes, so looking at this now again, we discover that c minus a is common to these two, so we can factor that out. Next, we have our a minus b times b minus c. And then we are factoring our c minus a out. Sorry, c minus a into b, this b is here, plus c plus a. So the next step now, we can just open this bracket and rearrange. So we have a minus b, b minus c, c minus a. Then we can reduce the bracket, make it smaller since we're opening this one. We can rearrange now since they're all added. So it's something as saying a plus b plus c. And there we have it, our answer. So please stay tuned for more videos, and don't forget to like, subscribe, and click the notification bell to get more videos such as this. See you in our next video. Thank you very much.